Hey, take a quick look around you. Your phone screen, the window, even the walls. We are absolutely surrounded by surfaces. But let's be honest, we almost never give them a second thought. Well, today, that's going to change. We're about to pull back the curtain on some incredible invisible technology that's giving these everyday materials honest-to-goodness superpowers. So just imagine for a second, what if the glass on a skyscraper could not only look beautiful, but also generate power? Or what if your window could literally sense the temperature and decide when to block the sun's heat? This isn't science fiction, folks. This is happening right now, and it's all thanks to some really mind-bending science.
Okay, so how is any of this even possible? Well, it all comes down to controlling materials at a scale that's almost impossible to imagine. We're going to dive right into the science behind these supersurfaces, getting down to the very atoms and molecules that make all of this magic happen.
Now, when I say coatings, I don't want you to picture a thick layer of paint. No way. We're talking about functional layers so thin they're completely invisible, something like 1,000 times thinner than a single human hair. And yet, this tiny, microscopic layer can fundamentally change the way an object works. The secret sauce behind all of this is a technology called thin film deposition. You could think of it like 3D printing, but instead of plastic, you're working with individual molecules. It allows scientists to lay down these incredibly thin films on a surface with insane precision, basically giving an object a brand new, high-tech skin. You know when you see those shimmering rainbow colors on a soap bubble? Well, there's no dye or pigment in there, right? That color actually comes from light waves bouncing off the bubble's super thin surface. That's the exact same principle at play here. It is literally like painting with physics.
All right, let's look at our first real-world example. We're going to take that whole painting with physics idea and apply it to one of the biggest challenges in green energy: how to make solar panels actually look good.
So we all know the deal with traditional solar panels. They're amazing at what they do, but they're also kind of big, clunky, and, well, they don't always look great on a building. The thin film solution to this is something called Building Integrated Photovoltaics, or BIPV. These are solar panels designed to blend in and become a beautiful, seamless part of the building itself. So, how in the world does this work? Well, scientists deposit multiple, ultra-thin layers onto the solar cell. And here's the clever part. They alternate between materials that bend light a lot and materials that bend light a little. By precisely controlling these layers, they can engineer that same soap bubble effect, creating specific, vibrant colors just by manipulating how light bounces around. It's basically functional art. So, just to sum it up, the core materials here are dielectrics, which are just electrical insulators that have different light-bending properties. They're applied using a method we're going to hear a lot more about called chemical vapor deposition, or CVD. And the final payoff is this perfect fusion of beautiful design and clean energy. Okay, so we've seen how these thin films can help buildings generate energy. Pretty cool. But now, let's check out how they can help buildings save energy, with windows that are way smarter than they look.
You know the feeling, right? That window that lets in beautiful, warm sunlight in the winter turns your room into an absolute sauna in the summer. Well, the solution is something called a thermochromic window. Thermo for heat, chromic for tint. It's a window that can literally change its tint based on the temperature, all by itself.
This amazing coating acts like a smart gatekeeper for sunlight. It's made from a material called vanadium dioxide. When it's cold outside, the coating is transparent, letting all that nice solar heat stream in. But once it heats up past a certain point, its entire molecular structure shifts, and it starts reflecting the heat away. And the best part? No wires, no switches, no moving parts at all. So the key material is that super clever vanadium dioxide. But to make sure it can last for decades on a building, it needs a really tough protective overcoat. That layer is applied using vapor phase processes, which makes sure the window can do its job of controlling solar heat for a very long time.
All right, for our last example, let's talk about something we've all dealt with. Let's tackle a problem that drives us all crazy every single day: fingerprints, smudges, and dirt on all our glass surfaces.
Think about it. Your phone screen, glass tables, display cases, they're basically magnets for fingerprints. But what if that surface could clean itself? It's totally possible with thin film coatings that make a surface hydrophobic. Think hydro for water and phobic for fearing. It's a surface that is literally designed to repel water and all the oils from our skin. So how do they pull this off? Well, they start with normal glass, which actually likes water. Then, using that same chemical vapor deposition method, scientists graft a microscopic layer of fluorinated molecules right onto it. This completely rewrites the surface's energy, flipping it to become hydrophobic. So now, water and oil just beat up and roll right off. It's amazing. And look at that, we're seeing a familiar pattern emerge, aren't we? The core material here is fluorinated groups, giving it that awesome anti-fingerprint quality. And the method used to put it there? You guessed it, chemical vapor deposition. It's pretty clear this process is the key to unlocking these incredible abilities.
And that brings us to the big reveal. We've just looked at 3 totally different things: colorable solar panels, windows that adapt to the weather, and self-cleaning glass. They seem completely unrelated, right? But they all share one invisible, incredibly powerful connection.
So what is it? What's the secret ingredient? What is that one single technology that ties colorful solar panels, smart windows, and self-cleaning glass all together?
It is chemical vapor deposition, or CVD. This is the master key that unlocks everything. CVD gives scientists precise atomic-level control, letting them build these films molecule by molecule. It creates layers that are perfectly even, crystal clear, and super durable. This is the foundational tech that makes all of these surface superpowers a reality.
So that leaves us with one last, pretty mind-blowing thought. We are literally learning how to program the function of a surface at the molecular level. We've taught them how to make energy, how to save energy, and how to clean themselves. So the real question is, what superpowers are we going to program into the materials of tomorrow?